All right, here we go with the final question on this little section. And we are going to look at when or what is the highest height that the ball will reach. So we had a moment ago, if you watched the previous videos, if not, I'll try to put links and all that stuff. But you know, oh goodness, that's terrible. How about a straight line? Okay. So generally, if the ball, starts 6 feet off the ground, right? It says that here, and we throw it up into the air and then it hits the ground at some point, right? We found that that's going to be at about 4.6 seconds. And so, and we also know when it's going to be 8 feet off the ground at 2 points in time here and here, roughly. And so now the question is, what's the highest height? Well, that's the maximum. We are finding the maximum height of this situation. Okay. And so this, for once, doesn't use quadratic formula, although I suppose you could use quadratic formula. To me, the more straightforward way is to think, okay, that maximum point is also the y value of the vertex. So we're combining or gathering all these things that we know to be true about a quadratic function and kind of just is all coming together, right? So let's find the vertex. Well, we're in standard form in our model here. And so we're going to use that formula -b/2a. And so I know ABC, right? So -72/2 times -16. -72/-32 is going to be a positive number. We know that. And let's just bring it right back in. So -72/-32 reduces to 9/4. So 9/4. Okay. So we know, and that is about 2.25, just by the way, because that makes more sense to me on a graph to change it to a decimal. You could always divide 9/4, or if you have a calculator like this, you can convert it this way, but 9 divided by 4 is how you would do that. It's just that fraction bar is just a division sign. Okay, so this is saying that at about 2.25 seconds, it's going to get to this maximum point, right? Okay, so we're trying to figure out what that height is. So now what we'll do is we'll take our function and let's think about, we just found the time at 2.25 seconds. This x is the time in seconds. All right, so I'm going to replace the t for time. I'm going to replace that with 2.25. Or 9/4, whichever you want to use is fine because it's the same value. Plus 6. Okay, so that all just plugs straight into the calculator. -16 times this squared plus that. And let's see what we get. Okay, so it turns out that when we do that, we get 87. Interesting. Let's think about what this means. This means that first of all, my graph is not very much drawn to scale because this is going up much higher than it's looking there, right? Which, I mean, as an A value of 16 is going to make it a very, very much taller, stretched kind of thing, but that's okay, because we still knew that this was a maximum point. Our sketch is just a sketch, right? And so the answer is that this ball is actually going to go 87 feet off the ground at its highest point. It gets to 87 feet and immediately begins to come back down to the ground level. All right. And so that we already rounded, well, no, that's an exact level, actually. It comes out perfectly. So we didn't have to round this at all. Works out. Okay. I hope that was helpful, and I'll see you next time.